So we can move to example 5, still on rationalization. Example 5 goes rationalize 1 plus root 3 all over 2 plus root 3. So we are going to apply the same ways of taking the conjugate, rationalizing the conjugate, that is rationalizing the denominator by taking the conjugate on both sides. Solution 1 plus root 3 all over 2 plus root 3 equals 1 plus root 3 all over 2 plus root 3 times 2 minus root 3, that's our conjugate, 2 minus root 3. So we are now free to open up the brackets. It will be 1 into 2 minus root 3, then plus root 3 into 2 minus root 3 all over, this one is a difference of 2 squares. Apply it, this is 2 squared minus root 3 squared. So what does it become? 1 plus 2. 1 times 2 you get a 2 minus root 3 plus root 3 times 2 you are getting 2 root 3 minus root 9 all over, what is 2 squared? You are getting 4 minus 3. We go ahead, this is 2. Then here you can see an element of this and this. We add them. Negative 1 plus 2 we are getting only plus 1 root 3. Then minus the square root of 9 is 3 all over 1. So this becomes 2 minus 3, you're getting negative 1 plus root 3 all over 1. That one becomes the correct example of that. So as we are moving on to the next examples, I want you to move with me. When I put an example, when you are there seated on your notebook, calculate it very fast. And then you can compare first. And then you compare. When I put the number, for you are free to first pause on, or you can first hold on the video. Then from there, first calculate it. Then at the end, compare yours and mine, and we see, are you correct? Or we may find that I'm not correct there. For you may calculate it more than me very fast. So let's look to another example, example 6. Example 6, saying rationalize 2 all over 2 plus root 2. So the same story with that, we are going to take the conjugate. Take the conjugate on the denominator. Solution 2 all over 2 plus root 2 is the same as 2 all over 2 plus root 2 times 2 minus root 2. What you do down to it also up 2 minus root 2. Then we are free now to open up the brackets. This will be 2 into 2 minus root 2 all over. This one is the difference of 2 squares. 2 squared minus root 2 squared. 2 times the 2 you are getting 4 minus 2 root 2. Very good. All over, what is 2 squared? You are getting 4 minus 2. Can we guide? This is the same as 4 minus 2 root 2 all over 2. And I said when you reach here, 2 divides every number. 2 goes there and also goes there. What do we remain with? We remain with 2 minus root 2. Because 2 is dividing every stuff. And then you have already come out with your perfect work. And even now you are free after getting mine. For you, as you have tried to pause on, you continue clicking as I have advised you. Then you see and you compare and contrast who has done it. I don't want you to trust my work and say, oh, that man is calculating. Trust you as first. Believe in you as. For us who have been doing these things for long, and that's why we are giving them to you. So I want you to get the content from me, then trust in yourself and say, I can also make it. If for him is doing it, why not me if I've been taught the same element? So another example goes, another example, that is example 7, goes, and we say rationalize 1 all over root 3 minus root 2. So what we're going to do, all of them, you can see they are under irrational numbers, but doesn't stop you. You do the same. Our solution, 1 all over 1c is going to be faster than me, equals 1 out of root 3 minus root 2 times root 3 plus root 2. What you do down, also do it up. Root 3 plus root 2. We go on. 1 times that remains as root 3 plus root 2 all over. This is the difference of 2 squares. This is root 3 squared minus root 2 squared. I think you're observing that element of the difference of 2 squares. So we go ahead, this is root 3 plus root 2 all over. These roots disappears, we remain with 3 minus a 2. What does it become? We are getting root 3 plus root 2 all over 1. Anything divided by 1 remains like that. So this becomes root 3 plus root 2. And you have already done that one. Then you are going to the another example, that is example 8, which you want now us to do together, which goes that rationalize root 5 plus root 3 all over. Then another example goes, example 8. And I promised I'm giving examples. How many examples? I said 8. Example 8. That means it's the last one in that. Saying rationalize root 5 plus root 3 all over root 5 minus root 3. So what we're going to do, it is the same story, the same format how we've been doing it. So we're going to say, so the same root 5 plus root 3 all over root 5 minus root 3 equals, this is root 5 plus root 3 all over root 5 minus root 3. We are now taking the conjugate. We are busy taking the conjugate on this. This becomes root 5 plus root 3. What you do down, also do it up. Root 5 plus root 3. So when we reach there, we use the Lehmann's understanding to open up those Sadic numbers. So this one becomes root 5 into root 5 plus root 3, then plus root 3 into root 5 plus root 3 all over. This one is the difference of 2 squares, as we have already seen it. This one becomes root 5 the whole of it squared minus root 3 the whole of it squared. So we go ahead and open up our own brackets. So what we're going to do is that root 5 times root 5, as we are following that one, becomes root 25 plus root 5 times root 5, you get root 15 plus root 3 times root 5, all of them, they are irrational numbers, we are getting also root 15 plus root 3 times root 3, we are getting root 9 all over. That one is the difference of 2 squares, as we have said. The roots are even cancelling. We are remaining with 5 minus 3. We go ahead. 25 is a perfect square. The square root of 25 is already 5 plus root 15. They are the same. This you can say root 2 root 15 plus, do you know the square root of 9 is already 3 all over 2. We go ahead and we collect like terms. 5 plus S3, we are coming out with 8 plus 2 root 15 all over 2. Then when you reach here, 2 divides every number in that side. What I'm getting, 2 can go in 8, how many times? 4. Plus also 2 can go there, that is once, we remain with root 15. And we have already simplified our number to the best. That's how we do these ones. As I've said that I've given you all these examples, I beg that you go and open chapter 9 in the pure one. Do more practice on that. When you fail, submit a number on our website. We shall try to help you and get the more on that. Otherwise, for now, let me wish you the best in as far as indices, SADs, and logarithms are concerned. And that's the end of that topic. So we are going now to open up a new topic when it comes to the next time. Otherwise, I wish you the best when it comes to